Okay. Hi, everyone. My name is Rabbi Ira Evan, and we are honored and excited to be able to present to you OHAV Connect and our speaker of this evening, which is Dr. David Hauser, and his class is Physics in the Torah and the Torah in Physics. And normally I get to hear David, it's usually about 2, 3 in the morning. So here I'm actually hearing him, I'm going to be awake. Let's see if I understand him any better, I don't know. But this is all part of, and I want to thank David for volunteering to do this class with us tonight. This is all part of our OHAV Connect. Obviously, we're in an unideal situation. Our shuls may be closed, but the shul is still, the doors may be closed, but the shul is still very much open. So we'll be recording this and sending this out to, on Facebook and on our social media. But this is all part of our connecting with our membership, or even the broader membership, and the people who are joining us as well. Just to know is that we daven every morning and every evening together at 7:15 in the morning, and this week at 7 o'clock. I think next week it'll be 7:05 or 7:10. And we have regular classes, mine in the afternoon on Tuesdays and Thursdays at 1 o'clock, as well as on Thursday evening we're going to have this Thursday evening we have a of course sangria. Did I say it right? I don't know. How to make a special drink by Jordan Smith. We think. So you'll see that flyer as well. And we have classes next week. We're looking at doing some fun things together with our membership, a newlywed game, all this to try to keep our connection together as best as we can. I want to thank Jordan Smith for our chair of social programming for bringing her talents to the cyber world. I want to thank Matt Lerner for making this a reality with all of the technology that goes involved in it. I want to thank all you for coming and being able to connect with us this evening. And I hope you learn as much as I always learn with David. So I'm going to turn the floor over to David Hauser, Dr. David Hauser, PhD. He has a whole list of things that he's accomplished, but I didn't write him down. So I'm sure he's a really smart guy. And we thank him for teaching tonight. We turn the floor over to Dr. Hauser.
Okay, super. Thank you. If you see me glancing to the left or to the right, it's because my normal workstation at home, I've got 7 monitors. So lots of different things. Okay, so thank everybody for the introduction, and thank you to Jordan and to Darren and to the rest of the board for enabling these sessions. We're going to talk about physics as a continuation to what I generally talk about at Tikkun Leil Shavuot. So I'm actually going to touch upon something we talked about at the last Shavuos, but then we're going to build off of that. Now, before we get into that, most people are actually surprised that there really is physics and mathematics in the Torah. So we're going to demonstrate it, but we're going to do more than just demonstrate it. We're going to look at some cutting edge stuff and how the Torah actually implements these equations and defines them. But before we do that, I am showing here, I don't know if you can see it well over a web camera, I'm showing here one of my son's plastic fruit. Okay, it's an apple. My question to everybody, what color is this apple? Now, it may be hard to see, but most people would say this apple is red. Here's the problem with this question and the answer. It seems like a very objective question, an objective answer. It's red. Very simple. Nothing complex about the question, and our ability to detect color is not a problem. The issue is, no matter how objective we think we are really highly subjective, even in identifying that as red. Here's an example. Human beings are called trichromats. In the back of the human eye are a bunch of cells that can detect color called cones. These rods and cones collectively initiate our ability to see black and white and color. And there are 3 colors that they're sensitive to: red, green, and blue. And the subset of light that is red, the subset that's green, and the subset that's blue is all we can detect. So when we see an object and we say it is red, within our limited ability, it looks red. However, there are a lot of animals in our world that can see more colors than us. For example, goldfish and pigeons can see colors that we can't. They can see ultraviolet, infrared. In fact, when they see this plastic apple and they see the subset of light that is infrared mixed with the subset that's red, they see a very different color. You and I are colorblind to infrared. We're colorblind to colors that we simply can't see. We don't even have a word for a color that is red mixed with infrared. We don't even have a word for it. Yet pigeons see that perfectly clearly and see it differently than you and I because they can see more colors than us, which means no matter how objective we think we are being, we need to really remember that our objectivity is quite subjective. For example, if you look at the illustration on the right of the screen, one person sees a 6 while another person sees a 9. Okay, we know it's a silly illustration, but it does point to that our perspectives are going to be different. Take a look at the Magen David in the middle of the screen. Everybody sees the Magen David? You look very carefully, there is no Magen David. Those 3 Pac-Man images make it appear as though we see a triangle, giving us the false impression that there exists a Magen David. Or if you look at the optical illusion on the left, how many beams are there? Are there 7 beams or are there 10? Now, this is an illusion. There actually are none. But no matter how convinced we are of what we see, we may not be correct. No matter how convinced we don't see something, we may not be correct. And no matter how objective we think we're being, something is red, we actually could be quite wrong. And the study of physics and science in general has suffered from these kinds of problems for millennia. We used to believe the Earth was flat, and we were convinced of that, and any evidence otherwise, we dismissed. We used to believe the Earth was the center of the universe. Then we used to believe the sun was the center of the universe. Every time we grow in our knowledge, it challenges our beliefs, no matter how objective they have been. So when we study physics, we are really studying elements of the world and how it's changed our perspectives. Now, when we study Torah, there you go. When we study Torah, we don't even realize most of the times the extent of the math and science that's included. Now, we've discussed it in the past many years during Shabbos, but more than just discussing it, we often misunderstand. We don't even attempt to interpret when we see so many numbers presented to us in the Torah. But there are so many details, from the properties of water to the miracles that are discussed. It's tremendous what's included. So, as a recap to something we talked about during Shavuos, is where we're going to start. We're going to actually do a series of exercises, but like any exercise, we need to warm up. We got to stretch a little bit. So we're going to start off easily and work our way to the more interesting. Let's see how it goes. First, we're going to start off with easy stuff. Einstein introduced an equation to the world, E equals mc squared, about 100 years ago. And this equation, which was mind-boggling and still is incredible today, tells us how much energy is in an object. So let's suppose I've got a rock. If I'm holding a rock in my hand, how much energy is in it? Now, in the classical physics world, we talk about the kinetic energy. If I throw the rock, I've imparted energy into it. Or if I drop it from the air, the gravitational pull, the potential energy associated with that, we talk about that kind of energy. But Einstein realized there's a lot more energy than that. If you were to look deep inside a rock, you would see it's composed of a bunch of atoms, electrons, protons, and neutrons. And in the middle are these protons and neutrons. And around the outside are these electrons that move really quickly. How fast do the electrons move? At the speed of light. And we use the letter C to represent that. So we know that there is an electron that's going around the atom at c, the speed of light. But if the atom, if the rock is very big, there's a large mass, there are many of these electrons. Now, why does the electron keep going around, and why does it not just shoot off? Shouldn't it just eventually shoot off? Well, because, and it doesn't, because it's negatively charged, and in the center of the atom are a bunch of protons, which are positively charged. And negative and positive charge atoms, particles pull on each other magnetically, and they attract. So even though the electron wants to shoot off, it's being pulled back toward the center by this positively charged and magnetic force. So we know the electron is moving at the speed of light, c. We know the magnetic force, the attractive force between the electron and the proton, has to overcome c, which is why we have this chi-squared term. Okay, E stands for energy, m is the mass of the object, and c is the speed of light. That's the equation. Okay, enough physics for now. Where does this equation come from? Now, this is a review for those who came to our session in Shabbos last year, but we need to start with the review and work our way up. Where does E equals mc squared come from? It comes from Bereshit. It's listed in 2 different places. We're only going to look at one place for now. In the beginning, Bereshit, verse 1. In the beginning, Bereshit bara Elokim et hashamayim et haaretz. In the beginning, Hashem created the heavens and earth. We've read this plenty of times. We know what this is about. In the beginning, Hashem created the heavens, which is the universe. It's the space, it's everything, and the earth. That's the ball upon which we live. What is the shape of the earth? It's approximately a sphere, and it's a very large ball, and Hashem creates the heavens and this large sphere, this ball. That's it. First pasuk, Hashem creates the heavens and this ball, the earth. The second pasuk, Va'aretz hayta tohu vavohu. Now the earth was unformed and void. But the first pasuk said Hashem created the earth. You know the earth is a sphere. But the second pasuk says the earth was unformed. How can it be unformed? We know the form of the earth is a sphere. It's a little confusing. Doesn't the second pasuk contradict the first pasuk? If the first pasuk Hashem makes the earth, but the earth is unformed, that's very strange. Well, I've got a question. How does the earth maintain its form? The way it maintains its form is gravity. There's no glue holding all the particles of earth together. It's gravity. And gravity is the attractive force of all these particles that maintain the shape of the earth. So we know the earth is a sphere. We know Hashem creates in the first pasuk. But the second pasuk says the earth is unformed. If it's not holding its spherical form, why not? It perhaps means no gravity yet. Maybe Hashem makes the earth, but in the second pasuk, we don't yet have gravity. But then the pasuk continues. And darkness was on the face of the deep. Darkness was everywhere. What is darkness? Darkness is the absence of light. What is light? Well, if you went back to the atom, and you have the electron going around the periphery, and in the center you have the neutron and the protons. When the electron changes orbits, when it goes from a small orbit to a much larger orbit, it releases energy. It's called a photon. This photon of energy, which leaves this atom, hits us in the eye, and we call it light. If darkness was upon the face of the deep, if there was darkness everywhere, meaning there was light nowhere, that means we don't have any atomic properties occurring. Because a standard atomic property is when the electron changes orbits. So let's recap. The earth was unformed and void. We probably don't have gravity yet. If darkness was everywhere, there's absolutely no light, that means we don't have atomic level physics either. So far we don't have gravity, physics over long distances. We don't seem to have physics over tiny distances. That's how light is created. And then we move into the next part. The next part of the pasuk says, "The ruach Elokim mirachepet al pnei hamayim," and the spirit of Hashem hovered over the face of the waters. Now that's a very strange sentence. If the first pasuk, Hashem is creating heavens and the earth, the second pasuk is implying no gravity, no light, no atomic level physics. And then all of a sudden Hashem talks about ruach Elokim, the spirit of Hashem. How do we go from discussion of physics to a discussion of metaphysics? That seems odd. Well, ruach has another definition. Ruach also means wind. What is wind? Wind is the movement of air from an area of low pressure to an area of high pressure. That's physics. Ruach also means energy. If all of us were singing Shmirot and the room was filled with energy, with ruach, that also means energy. So what is ruach? Well, ruach, meaning energy, Hashem is telling us, there is no energy yet. There's no kinetic and potential energy. That's why we don't have the gravitational forces, which is the source of potential energy. We don't have atomic level physics yet. And all of a sudden, Hashem gives us ruach Elokim. What happens if you were to buy a brand new electronic device? What's the first thing you do when you get home? You plug it into the wall. First thing you do is when you take an empty battery, you plug it in. We don't want to plug in batteries that are fully charged. It's not a good idea. We want to make sure that there's no energy in the battery before we plug it in. So we should check. If our phone is on 5%, then we can add energy into it. We don't want to fill up our car with gas if the car is already full of gas. We want to make sure that the energy is low. Hashem is telling us, in verse 2, that there is no energy yet, and therefore tells us Ruach Elokim. So Hashem introduces us to Ruach Elokim. Let's move on. Third pasuk. Vayomer Elokim Yior Vayior. Hashem said, "Let there be light," and boom, there was light. So we already know from the second pasuk, darkness is everywhere, which means we don't yet have the atomic level physics. So when Hashem says in the third pasuk, "Let there be light," that means Hashem is now turning on the atomic level of physics. The English translation for the third pasuk is not a great translation. It's a common one, but it's not great. The translation is on the screen, and it's typically used is, Hashem said, "Let there be light," and then there was light. Hashem said it, and then boom, it happened. But the Hebrew does not quite translate that way. The Hebrew actually says, Yior by Yior. There will be light, and there will be light. There will be light, and there will be light, implying two different types of light. Actually, that's true. Scientists tell us there are two different types of light. There's the visible light that you and I can see right now, and there's the invisible light that we can't see, such as gamma rays and X-rays and microwaves and all the other light that other animals, by the way, that can see that you and I can't see. So scientists tell us there are indeed two types of light. Let's recap. The first pasuk, Hashem creates the universe, like heavens and Aretz, and the land and the earth. He creates the mass. Second pasuk, the mass has no energy yet. It's got no gravitational physics. It's got no atomic level physics. First pasuk, Hashem creates the mass. The second pasuk, Hashem gives us Ruach Elokim, gives us energy. We have the mass in the first pasuk, Ruach in the second pasuk. And what do we get in the third pasuk? Yior by Yior. Hashem gives us light 2 times. The first pasuk we get mass. The second pasuk we get energy. The third pasuk we get light 2 times. The equation E equals mc squared is mass, energy, and light 2 times. And the very beginning, while Hashem is creating all of the universe, he is turning on the laws of physics. And we know in pasuk number 4, and Hashem saw the light, and it was good. Well, what does that mean? Vayar Elokim et or kitov. Well, it was good. What does that mean it was good? Well, what it seems to imply is that when Hashem made light, that it's consistent. If light is better here and not so good here, if sometimes the atom does a great job in creating photons of light, and sometimes it does a bad job in creating photons of light, well, that's not good. For it to be good implies that it's consistent, meaning light anywhere must be done precisely the same way, implying that perhaps these laws of physics are consistently applied everywhere. So remember, this is just a warm-up, and hopefully you recall seeing this when we spoke the last time. Okay, what we haven't defined is, well, what is physics? We understand that physics is in Torah. We see that E equals mc squared is built into these psukim. We haven't defined physics yet, so let's actually do that. Physics is the study of 3 dimensions: time, space, and mass. Study of 3 dimensions. In fact, what is time? Time is the study of 3 dimensions: past, present, and future. What is the study of space? Length, width, height. What about mass? You know, mass has 3 dimensions too. All mass is made up of electrons, protons, and neutrons. All mass is made up of particles that are positively charged, neutrally charged, or negatively charged. Matter takes up 3 different states: solid, liquid, or gas. So we know that these 3 dimensions are continuously thrust upon us. Question: where do these 3 dimensions, time, space, and mass, come from? Let's go back to the first pasuk. Bereshit bara Elokim. In the beginning, what did Hashem create? Well, the very first word is Bereshit. The first word we're introduced to is time. Then bara Elokim et hashamayim. Then Hashem creates shamayim, space. So we're given Bereshit and then shamayim. And then what are we given? Ve'et ha'aretz. And then the mass. In the very first pasuk, we're given Bereshit, shamayim, ha'aretz. We're given Bereshit, time, shamayim, space, and ha'aretz, mass. Notice the order that Hashem gives it to us. Hashem gives us time, followed by space, followed by mass. What if Hashem did it in a different order? What if we had mass before space? Well, then where would you put the mass? What if you had mass before time? Well, when would you put the mass? So the order that Hashem introduces it is quite logical. Okay? So we understand that physics clearly has some sort of tentacles into the text. Let's move on. There were some very strange things that Einstein gave us when he gave us E equals mc squared. In fact, all of it seems very counterintuitive, yet it is the standard of all modern physics today, which is Einstein's theory of relativity. Let's take a look at it. First, where does the theory of relativity come from? It comes from Parshat Beshalach. It comes from in Shemot. Now, before we get to that, let's take a look what it says. We learn in Parshat Beshalach, right after the Israelites, our ancestors, were finally released from slavery. They're in the desert, and how they get the food? Hashem provides the man. And there are a bunch of miracles associated with the story that's described in this. Here are 4 of the miracles. The first miracle is the fact that Hashem provided the man. We take for granted every day that the food we eat is itself a miracle. That's why we make a bracha. We try to, everything we eat, every big and small, we always try to make a bracha to remind ourselves how lucky we are to even have the food. In any event, the man, which came from heaven, motzi lachem min hashamayim, the man is miraculous in of itself. But there are many miracles associated with it. For example, if a person took their man on Tuesday and saved it for Wednesday, it would spoil. Now, that doesn't seem to be too miraculous. We have food that spoils from one day to the next. But what's so miraculous about that is the man that they saved on Friday to be used on Shabbos did not spoil. So we were told on Friday we take a double portion of man. So for the purpose of not having to collect it on Shabbos, it's why we have two chalot. But the fact that the man had to itself know what day it is to know if it should spoil if saved or not spoil if saved. But the other thing that's miraculous is the physics and mathematics of the man. Now, before we get into the physics and math, we need to change gears for just a moment and get into Einstein's relativity. Then we'll come back to that. So here's a math problem. Let's suppose you and I are running away from one another in our social distancing at the speeds as listed on the top of the page. Suppose I am running at v miles per hour to the left. So perhaps I'm running at 20. I'm running 20 miles an hour to the left. At the same time, you are running at w, 20 miles an hour to the right. That's it. I'm running 20 miles an hour to the left. You're running at 20 miles an hour to the right. Question, how fast are we social distancing? How fast are we separating from one another? Well, when we think about this, if I'm going at v to the left, you're going at w to the right, it seems logical that perhaps it's the same as one of us not moving and the other one moving at v plus w, or 40 miles an hour. They seem to be equivalent. This seems to suggest how fast we are social distancing. Pretty straightforward. Using basic logic, we derive the equation v plus w. Pretty straightforward. Here's a not so simple math problem that appears simple. What if I am moving at warp 0.9? That means I'm moving at 90% of the speed of light. I'm moving at 90% of the speed of light to the left, while you are moving 90% speed of light to the right. Well, how fast are we social distancing? It should be equivalent using the logic that we had before. One of us not moving, and the other one is moving at v plus w, or 1.8 times the speed of light, warp 1.8. Doesn't seem problematic. However, scientists tell us this is highly problematic. They say nothing can move faster than the speed of light. It is not possible to go faster than c. If that's the case, what's the problem? Isn't it true that if I'm going 0.9 c in one direction, you're going 0.9 c in the other direction, it is the same as one of us not moving, the other one moving at 1.8 c? That seems the way it should be. Scientists tell us, however, that time and space warp at high speeds. Hence the word warp for these speeds. At very high velocities, Einstein tells us time and space warp. It's a weird concept. He actually, and I'll describe the proof later. We're going to look at the proof later. In the meantime, he said it is not true that our speeds are v plus w. That's how fast we're social distancing. It is not true. The equation he actually gave us looks like this. Instead of v plus w that we have been using the last few slides, he actually takes v plus w and divides it by this other term. 1 plus v times w over c squared. Remember, c is the speed of light. That's a weird looking equation, but that's what Einstein gave us. So he said at these high velocities, things behave very differently than what we'd expect. Let's put the math into play. If I am moving at 0.9 speed of light, if v is 0.9, I'm moving 0.9 to the left, and you are moving at 0.9 c to the right. Instead of just simply adding our velocities, I'm going to plug these into the equation that Einstein gave us. So v and w are 0.9 c in the opposite directions. When I plug it into this equation and I run through the arithmetic, when I am moving at 90% of the speed of light in one direction, you're moving 90% of the speed of light the other direction, space and time warp such that it is equal to one of us not moving and the other one moving at 99% of the speed of light. In other words, at these humongous velocities, these crazy velocities, time and space are warping that we are not separating at 1.8 warp. We're separating at 0.99 warp. That seems really weird. This is the physics that was introduced 100 years ago and has been proven over and over and over again to be accurate. Proven over and over to be accurate. I will describe the proof later. Let's now go back to Parshat B'Shalach, because Parshat B'Shalach introduces an answer to this question. It says in verse 16 that everybody, when giving the rules for the man, is to go out and collect man. And it says, everyone, verse 16, this is what Hashem has commanded. Everyone is to gather what they need. Take an omer, that's a unit of measure. Take an omer for every person in your tent. If I'm a family of 5, I need to take 5 omers worth. If I'm a family of 20, I need to take 20 omers worth. If I'm a family of 2, I need to take 2 omers worth. An omer is a unit of measure. That's it. That's the specifics. Everybody's to take exactly what you need. Verse 18. It says, however, when they measured it by the omer. As soon as we hear measurement, we should think science. Science measures things. And if you're going to compare it to an omer, what if I have a balance? I have a scale. And I put the man that you took on one side, and I have a weight on the other that's exactly set to an omer. I should be able to measure it. And it says when they measured it. Let's continue. Those who gathered more, if you took more than you're supposed to, remember, you're not supposed to take more than an omer. Those who gathered more did not have more. You have the correct amount. And those who did not gather enough, those who gathered too little, did not have too little. So it says when you measured it. Now let's remind ourselves what equation 1 is. Scientists tell us that no matter how fast V and W seem to be, no matter how fast I'm moving to one direction, you're moving the other direction, space and time warp, and equation 1 says, C, our speed limit. Nothing will ever move faster than the speed limit. That's the equation number 1 that Einstein gave us 100 years ago, that physicists still use to this day in every possible way. So equation 1 is part of a special theory of relativity. That's the speed limit. It says in verse 18, when you try to take too much man, you will not have too much man. And we're told in verse 16, the amount of man you can have is an omer's worth. There is a man limit. You can't get more man even if you try. So we have a limit of man. We have a limit of speed, equation 1. Well, that means if I try to take too much man, there's a man limit. Equation 2 and equation 1 are, except equation 1 is Einstein's equation for speed limit. And equation 2, I guess, is B'Shalach's equation for the man limit, where instead of using C as the speed limit, M is the limit on the man. Now, let's remind ourselves what verse 18 says. Those who gather too much man. Let's do that scenario. The specific scenario that's in verse 18 is when you take too much man. So let's do that. Let's take twice as much man as we're supposed to. Here's the scenario. I'm going to go out in the morning. I'm going to get V, the amount of man. I'm going to go home and put it in the fridge. So let's suppose I take M pounds of man. Go home, put it in the fridge. In the afternoon, I'm going to go take another M pounds of man. So we think it should be M plus M. If I took M pounds of man in the morning, and I took another M pounds of man in the afternoon, I should have 2M sitting in the refrigerator. That's what we think. But let's apply Einstein's relativity equation. If the amount of man, V, I took in the morning, plus the amount of man, W, I took in the afternoon, when I plug it into this equation, knowing I took M pounds of man in the morning and M pounds of man in the afternoon, I get equation 3. I just replaced V and W with M. And I see I get M plus M in the numerator, that's 2M. And I get M times M in the denominator, that's an M squared. And you can see that M squared of M squared will cancel out. And what do we get? We get what the pasuk says. The pasuk says, when you measured it by the omer, those who gather too much, in our case, twice as much, did not have too much. You had the right amount. Let's do something silly. Let's be ridiculous. Instead of taking twice as much, let's take 17 times too much man. Let's be absolutely ridiculous. Here's what happens. Go out in the morning, we get our N pounds of man, go home, put it in the fridge. Go out in the afternoon, and now I'm going to take 16 times too much more stuff. So V is going to be M, W is going to be 16M, for a total of 17. 17 times more man than I'm entitled to. So let's do that scenario. Let's replace V with M, the amount of man I took in the morning. Let's replace W with the 16M extra man I took in the afternoon. M plus 16M is 17M. In equation 3, where I've got 1M times 16M, that's 16M squared. The M squareds cancel. And I still have M. When you, according to verse 18, When you measured it, those who gathered more did not have more. Even though I took 17 times too much mon, when I measured it, not what happened. I had the correct amount, exactly as the pasuk explains. But the pasuk continues. Read the end of verse 18. Those who gathered too little did not have too little. Well, let's do that scenario. Let's take half as much as we're supposed to. So here's the scenario. We go out in the morning, we get our M pounds of mon. On the way home, half of it falls out of our bag. So V, the amount of mon we took in the morning, is M, the right amount. W is negative half, because half of it fell out of my bag on the way home. So I'd expect V plus W to be half the amount I'm supposed to have. So I'm going to replace V and W with M and negative half M in the same exact equation. Now, some people are not comfortable with fractions and negatives, but good to hear. But trust me, the math that was done correctly. It reads in the numerator, M plus negative half M is the same thing as M minus half M. In where we have M times negative half M, it's the same thing as negative half M squared. The M squareds cancel, and we get, when we measured it by the Omer, those who gathered too little did not have too little. Same equation. All the scenarios that are presented in this psukim are exactly as the physics predicted. When most people read these psukim, they disregard, they assume it, they try to interpret it. The physics is precise. Now remember, we're just warming up. We just did something that people have seen in the past. If you were at the Shabbos last year. However, what are we warming up to? Well, let's go a little deeper into the physics now. Einstein gave us a very strange equation. Warm-up number 3. We're building to a really crazy end. Einstein gave us another equation about time. And this equation says the following. The faster an object moves in space, the slower it moves in time. And the equation he gave us has V, that's the velocity of an object. If we're running at 20 miles an hour, that's our velocity. C, that same C you saw before. You saw it in E equals MC squared. You saw it in Bishalach. That C is the speed of light. And this equation tells us how time warps. Very strange concept, but here's a very strange thought experiment. How old are you and your identical twin? So let's do the following experiment. Suppose one twin, you and your twin are born at the same moment. One of your twins, you're not moving. You stay right here. And the other twin gets into a car and now drives at 10 miles an hour. That's it. Keep going at 10 miles an hour. It's a very silly experiment, but we'll do that. The moment you're born, you stay here. Your twin gets into the car and they're driving 10 miles an hour. And they do not stop. When you are 20 years old, how old is your twin? Your twin is, when you plug the same information, guess what? They're 20 as well. Nothing unusual. But there is something unusual. Remember, at high velocities is where time and space warp according to the physics. Let's take a look at this now. Let's change the problem. When you and your twin are born, you're not moving. You stay right here on Earth. But your identical twin gets into a rocket. And this rocket is now going at 80% of the speed of light. And that's a pretty high velocity. And they travel around 80% speed of light. When you, here on Earth, are 20 years old, what is the age of your twin? Well, logic would tell me 20. It's not what the physics tells us. I'll describe the proof in just a moment. Let's plug this in. The person not moving is T0 is 20 years old. The velocity of the person moving is 80% of the speed of light. Since I know the speed of light is 6.7 times 10 to the 11th, that's the speed in meters there. 80% of that, I get 5.4 times 10 to the 11. I'm just plugging in the velocity based on being 80% of the speed of light. And when you run through the arithmetic, when you are 20 years old, your sibling is 12 years old. Doesn't make sense. Scientists tell us the faster an object moves in space, the slower it moves in time. It is really weird, but this has been proven over and over and over again. Let me give you an example of the proof. And there are many proofs. Just give an example of one of them. Something called an atomic clock. What's an atomic clock? It's a clock that has inside of it a cesium atom. This cesium atom has a very peculiar property, which is when it's exposed to an electric field, it vibrates. And it vibrates a specific amount of times. In fact, you can count the number of times as the basis of a clock. So when you expose it to an electric field, it doesn't matter if it's a strong electric field or a mild one, it vibrates the same amount of times every time, in every condition. That's true on the top of a mountain, it's true under a cave, it's true on Earth, doesn't matter where it is, always vibrates a fixed number of times. So the atomic clock, based upon the cesium atom that's vibrating, is what happens. We have satellites, we have thousands of satellites in orbit. We use them for internet connectivity, we use it for telephone calls, we use it for GPS, and they're orbiting our planet at many thousands of miles an hour. They send information back to the Earth, and the information comes with a timestamp. And they have found that even though they're using a cesium atom, even though when it was launched from Earth and the clocks were perfectly in sync, as it orbits our planet at many thousands of miles an hour, it is losing time. The clock is moving slower. It is vibrating slightly less based upon the precision of this equation. And this has been demonstrated time and time and time again. Okay. Now, let's talk about something controversial. Okay, controversy is fun. Let's talk about controversial. According to NASA, we are moving pretty quickly in space. Now, I'm not trying to sell you on is the Big Bang Theory valid or invalid. This is just what NASA has reported. Now, according to NASA, approximately 14 billion years ago may have been a Big Bang. And the idea is all the matter in the universe was, according to the theory, in one little spot. And then it exploded. And in the process of exploding, all the particles are moving farther away from us. And we actually have a sense that this might be true, because when you look out into the heavens and you see stars over there moving away from us, and you see stars over there moving away from us, well, if they're moving apart from us, and you look in all directions, and most everything in the universe is moving farther away from us, it suggests, well, they are separating. Well, what causes it to separate? Maybe they were closer together, and they exploded. And the estimates based upon that are about roughly 14 billion years ago, all the matter in the universe was in one spot, and it exploded. That's it. That is the theory. There's a lot of controversy in this theory. It is one of the more famous theories, but is by no means the only theory in science. But because it's the famous one, we're going to tackle this one. There is another piece of controversy associated with something called the Hubble Constant. It's a way of estimating how fast things are moving. Okay? What's so controversial about it? If you look up into the heavens and you see there's a galaxy to your left moving at 90% of the speed of light to your left, and there's a galaxy on the right moving at 90% of the speed of light to the other direction, how fast are they moving apart from each other? That's the controversy. Because the earlier equation says, well, yeah, it's moving quickly to the left, one's moving quickly to the right, I can't just add their velocities. It's a very controversial number. How do you figure out how fast the universe is expanding? So I'm just going to use one of them that's published. Okay? There are many numbers. Some numbers suggest the universe is expanding at a rate faster than this. Some suggest it's expanding at a rate slower than this. Whatever. I'm just going to use this particular number. Okay? And there are many estimates that says it's faster. Many estimates that says it's slower. I'm just going to use this particular one here. Okay. Let's suppose the Big Bang is correct. And let's suppose everything is indeed expanding at about 99% of the speed of light. Okay. Now, let's remind ourselves that we have Rosh Hashanah coming up. You know, we learned that the Torah clock tells us we are 5,780 years old. Coming up on 5,781 in a bunch of months from now. We teach the world is 5,780 years old. Simple. Scientists tell us that we are moving at about 99% of the speed of light, the expansion of the universe. And scientists also tell us that the faster an object moves in space, the slower it moves in time. Let's do an experiment. Here's the experiment. Let's suppose it is true that all the matter in the universe was in one tiny little spot, right here, right in your living room, wherever you're watching this discussion. Suppose all the matter was in that little spot, and then it exploded. Let's do something. Let's have two clocks. One clock we're going to put on the matter that's exploding and moving away from that center point. So we've got one clock that is moving with the expansion of the universe, and that one clock is moving at 99.999% of the speed of light. Let's have another clock that's at that point where everything exploded from. That clock's not moving. That clock is going to stay wherever the Big Bang started. If the Big Bang occurred in your living room, then you're going to have one clock in your living room. It's not going to move. The other clock is going to move with the exploding parts that are moving away. So we've got one clock that is not moving and one clock that's moving at 99.99% of the speed of light. Assuming physicists estimates that the speed with which we are moving is 99% of the speed of light, and assuming Einstein's special theory of relativity applies, let's plug the information that we know. So Torah teaches us, Judaism teaches that we are 5,780 years old. Scientists tell us that's one clock. One clock is 5,780. Yet the other clock is moving at 99% of the speed of light. And that clock that they both started at the same time. They're both identical twins. One is not moving, it's at the location of the Big Bang, whereas the other one is moving with the expansion of the universe. So one clock is not moving, it's 5,780 years old, yet the other clock is moving at 99.999% of the speed of light. So let's plug the information in that we know. And when we do that, and we run through the arithmetic, we calculate that one clock is going to say 5,780 years, while the other clock is going to say 14 billion years. Now, this is not meant to say it is right or it's wrong. It's not meant to say that, hey, NASA may have a point. Not meant to do that at all. What it really says is we need to look at some high-end complex physics to appreciate the fact that there is no disconnect between these two. Remember, this is just a warm-up. It's a crazy warm-up. What are we warming up to? Let's move on in the physics of theory of relativity. Let's go back to E equals mc squared. Warm-up number 4. We're just warming up. How do we use E equals mc squared? Well, the way we use it is through a fission reaction. Here's what happens. If there's so much energy in a rock, how do I get the energy out? Well, let's take a look at how a fission reaction works. We have a uranium nucleus. Uranium atom has a large number of protons and neutrons squished in the middle. Now remember, the protons are positively charged and they're squished together. Things that are positively charged want to push away from each other, but they're forced together because there's a bunch of electrons on the outside. They're negatively charged, kind of pushing it in. So they're squished together. The nucleus is squished together when it doesn't really want to be. It wants to spring apart because of all the positive protons in the middle. So what happens in a fission reaction? We take a neutron, which is neutrally charged, and shoot it at the nucleus. And when you do that, it imparts the kinetic energy, and it forces it to break up. In the process of breaking the nucleus into pieces, it releases a bunch of the energy, including it releases other neutrons. What do those neutrons do? Those neutrons bang into other uranium nuclei, which in turn releases energy and releases more neutrons. It's a chain reaction. So the way that we use fission reactions is how we power nuclear power plants, how we power nuclear submarines. That's how we power many of our homes. We use this equation. But in Masechet Avot, in Pirkei Avot, we're actually told about this equation and given us some warnings. Let's take a look at some of the warnings. We know that people can use this to power homes and do positive, but people can also use this in weapons and do bad things. And it says in Pirkei Avot that Ben Azai would say, run to pursue a minor mitzvah and flee from a transgression, from an avera, from a sin. Why? For a mitzvah brings another mitzvah, and a transgression, a sin, brings another transgression. And the reward of a mitzvah is a mitzvah. The reward, or in this case, the punishment for a sin is another avera. Let's go back to the beginning. It says, run to pursue a minor mitzvah. Why? A minor mitzvah brings another minor mitzvah. Here's an example. Before we had this social distancing, when you were at the grocery store and you brought your cart to the car, you know what you could have done is just left the cart. But you know, if a good, decent human being would spend the extra 30 seconds and bring the cart to the front. That's it. And if you do that, maybe next time you'll do it again and again and again. When you do these minor mitzvot that take no effort to do, it leads you to do another one. But what if somebody else sees you do it? Somebody else sees you do it. You're wearing a kippah. They see you doing that. You know, that reflects positively on all Jews when you do even minor mitzvot. When you're walking down the street and you see somebody who's hungry and you give them some money. A minor thing, it's not a big deal for us. But anytime we do a minor mitzvah, it leads to other minor mitzvot, which has the positive reaction. However, we are warned, flee from a transgression, flee from an avera, even a tiny one. Why? Because avera gereret avera. What if is a student who didn't study for a test. They completely forgot to study for a test. So during the test, when nobody's looking, they cheat. It's a victimless crime. Nobody gets hurt. Nobody's going to know. Nobody's going to care. Okay, so you simply cheat. That's it. A week later, you have another test. Oh, I forgot to, so you cheat again. A week later, you might say to yourself, you know something? I don't want to spend so much time studying. I'll study just a little bit if I, and they start to get used to the ability to cheat. And when they get used to that cheating, we are warned that mitzvah, gereret mitzvah, is great, but avera, gereret avera is the problem. When one fission reaction leads to additional power, that's excellent. But when one fission reaction leads to destruction, that is a serious problem, and it's something we've been warned about. We've been warned about this. Now, this is just basic physics. It may seem complex to some, but it's pretty basic physics. The Torah has a lot more than just physics. We've actually discussed other variations in the past. Let me just pull attention to one of them. Let's take a look at some numbers. Torah gives us numbers all the time. It gives us census count and ages and dimensions. It gives us so much. And what do we do when we see those numbers? We try to connect gematria. We try to interpret how the numbers may mean. Sometimes we disregard the numbers. Let's take a look at some of the numbers. We know in Breshit that Avram, Yitzchak, and Yaakov, according to these psukim, lived to be 175, 180, 147 years respectively. These are strange numbers. Why these numbers? It doesn't seem logical. We can try to interpret as much as we want. Hashem gave us the numbers. What are we supposed to do with it? Well, let's use a scientific perspective. Whenever we're given any data, is there a way we can study the data in a scientific manner? Well, the data we were just given on Avram, Yitzchak, and Yaakov's ages, 175, 180, and 147, actually have a very specific functional form. And they are based upon the triplet of product, 5 times 5 times 7, 665, and 773. I can multiply these three sets of numbers to get their ages. And you can see the pattern. It's not just a squared term. You got a 567 and a 753. You can see the order of these. You change any one of these numbers, it doesn't hold. Okay, it must be a coincidence. On the other hand, what is 5 plus 5 plus 7? What is 6 plus 6 plus 5? What is 7 plus 7 plus 3? Interestingly, they sum to the same constant. Perhaps it's a coincidence. But then the Torah gives us Yosef's age. Yosef is Yaakov's son. So we have Avram, his son, Yitzchak, his son, Yaakov, and his son, Yosef. And according to the Pasukim in Breshit, he lived to be 110 years old. It's explicit. It's not approximate. It says explicitly 110. And the 110 of Yosef is equal to the sum of the square terms of his father, grandfather, and great-grandfather. Must be a coincidence. Well, we know Avram's wife, Sarah. And according to Breshit, she lived to be 127 years old. And 127 years of Sarah is equal to the sum of the square terms of her husband, son, and grandson, and the constant term. Well, change any one of these numbers, it doesn't hold. Oh, and by the way, we already mentioned Yosef. Who was the first person and who was the last person mentioned in Sefer Breshit? The first person was Adam HaRishon, and the last person was Yosef. And according to their Pesukim, the first person and the last person, they were 930 and 110 years of age respectively. We're given the data. And these two people who never met, they didn't live in the same time period, first person and the last person mentioned, also follow identical functional form, n squared plus n. You change any one of these numbers, and it doesn't hold. The various Pesukim that talk about and illustrate and give us insight into the equations are so specific, but it takes advanced mathematics, advanced understanding of science in order for us to start to appreciate some of this. As an example, there are 40 prime numbers mentioned in the Torah. 40. Why 40? Why not more? Why not less? If you ever looked at those specific numbers, there are very specific properties behind those numbers. There are so many equations listed in the Torah. It is extraordinary, but it takes us putting on a scientific and mathematical hat to appreciate it. Now, we've been warming up. What have we been warming up to? Well, Rabbi Eben has often said, you should not say, you should only have simchas. Don't go up to somebody and say, you should only have smachot. Why not? What's wrong with saying that? I'm trying to be nice. Why don't we say you should only have smachot? Well, let's look at this concept through a mathematical lens. A person who lives their life full of love, it's a happy life. If they love their job and they love their community, they love their friends, and they love everybody, happy life. We know people who are truly appreciative of what they have. When you are appreciative, despite the bad things, happiness. There are lots of people suffering today because of coronavirus. Absolutely understand. But when you've got a good attitude, despite the challenges, that's a definition of a happy life. When you come across somebody who lives like this equation, we're very jealous of that. Why? Because it was so great to be such a positive outlook on life. Well, mitzvah gadola li'ot b'simcha tamid. It's a great mitzvah to always be happy. In order to do that, we need to be appreciative of what we have. This equation is an equation for a fulfilled life. Love everything about it, appreciate what you've got. That's the definition of happiness. There are people who live according to this equation. Perhaps there are times when we feel like this. Life without love. Oh, this is not good enough. I hate my job. I don't like the community. I always complaining. When you look for the bad things, when you struggle to appreciate what you got, how lucky you are to have what you have, that's the definition of a sad life. There are times each one of us feels like this. But there are people who are chronically stuck in this. In fact, the Aseret HaDibrot, the Ten Commandments, warns us against the second equation. Aseret HaDibrot tells us, don't be jealous of others. What does it mean to be jealous of others? It means they have something better than I have. What I have is not very good. I don't have the best of cars. I don't have the fanciest house or go on the greatest vacations. You're not supposed to live a life of jealousy. The life without love, without appreciation is sad. These two equations really underscore all different aspects of what our life is about and all the challenges we have in our life. When we look at this in equation format, we can treat them like any equation. And I can sum up these two equations. Life plus life equals 2 times life. Plus love minus love cancel each other out. So I get 2 times life equals happy plus sad. Strange equation, but I've got it. I can divide both sides of this equation by 2 to get rid of that 2, giving us life equals happy plus sad divided by 2. That shared denominator of 2 can be factored, giving us life is half happy and half sad. Now, this is actually important because we have mitzvot that relate to both of these. We visit the sick. We make a shiva minyan. We don't shy away from sad moments. We go out of our way to help in sad moments. We also have happy moments, and we have mitzvot that relate to happy moments. Life is actually full of both of these moments. And to say you should only have simchas, you should only shy away from the sad, well, there are sad aspects and troubling aspects of life, but life is a combination of both of these. And it's odd that sometimes it takes mathematical perspective to remind us of that. Just consider the situation we're in today. We all know what's going on. We all know that we're separated for a while. Why? Because of pikuach nefesh. What exactly is pikuach nefesh? It's a reminder of science. Pikuach nefesh is one of the Taryag mitzvot, one of the 613 mitzvot that says, if you have an opportunity to save a life, you must do so. You put aside most other mitzvot. If it's Shabbos and somebody is having a heart attack, you must pick up the phone and call for help. Absolutely, no hesitation. If there's a medicine that helps somebody, but it's made of something treif, but it's going to save a life, you absolutely use it. No hesitation. What exactly is pikuach nefesh? It's not just saving a life. It's putting aside some of the other mitzvot and prioritizing whatever we need to do. Pikuach nefesh is more about not just helping others, but it's embracing and reprioritizing. Here's an example. What does it mean to call 911? Right now, God forbid somebody was having an emergency, and we picked up the phone and called 911. What are we doing? We are leveraging science. Hundreds of years of research went into building the phones that we use today. Accumulated knowledge of science is what led to the fact that we are having this discussion over the internet right now. It's science that is allowing us to do this. You could have picked up the phone 500 years ago when, God forbid, there was an emergency, meaning we can do pikuach nefesh better now than in the past because we've leveraged science. When we, here's another example. Today, there are more people studying Torah than at any point in history. Hitler, Yamach Shemo, who murdered 1/3 of the Jewish people. And he murdered through Europe, where there were greatest institutions of Jewish learning, destroyed. Yet we have more people now studying Torah. Why? Because of science enabling us to do so. The internet, where we can share shiurim and sichot, we can do a search for Divrei Torah, Divrei Tefillah, is incredible that science has enabled it. But it's the Torah that actually is the seed for it. From the very, very beginning, the Torah is full of science. We haven't even scratched the surface. Everything from Einstein's warping equations to properties of water to Noah's Ark. There's so many different aspects, and we forget the miraculous nature of what science is doing. We're looking for cures right now for COVID-19, and God willing, we'll have them soon. What does that mean? It means that science is going to be saving the day, and we are prioritizing science. That's what the Torah is telling us to do. That's why it says in times of Pikuach Nefesh, put aside these things and go focus what you need to do to save a life. And what we need to do to save a life today is stay separated and invest in the science. And by doing that, we will have miracles beyond miracles. We forget that after decades ago and centuries ago and eons ago, when there were horrible plagues, when they eventually passed, it was miraculous. The best way probably to describe the science that's listed in the Torah is the way Ben Gurion did. Ben Gurion, when he was describing the state of Israel, said, if you don't believe in miracles, you're not a realist. The physics and the science and the mathematics that power our world today is real life. But so are the miracles that it enables. So the science that's in the Torah is just the beginning. So that's it. Thank you very much, everybody.
Thank you, David. Thank you so much. That was really great. It was there was some review there of stuff that I remembered at 2:00 in the morning, and now it made more sense than at 2:00 in the morning. We should have you speak earlier in the night, or when in the daylight hours. But we so appreciate it. Really, David is one of the great gems of our community and of our shul and of our greater communal family. We thank you for bringing us together today. Do you want to take any questions, or how do you want to do this? You want to go to sleep? Yeah. Okay. So then I'm going to figure out what to do. I am going to unmute all. Actually, other than this, if you want to ask a question, unmute yourself. Should be able to do that. You could just, where it says on the corner of, it should be on the corner of your screen, you can unmute yourself and, look at all these people that we're looking at now. And you can turn on your video if you want. It's nice to see who is here and everybody can connect. But if you wanted to ask a question, mute yourself. There
I am.
There we go. Okay. Does anybody have a question? Roni, have a question?
No, not really. I really enjoyed that stuff, though. Nice.
It was fun.
I was never a good physics student, but if I had you as a teacher, I might be better.
That's great. That's great. Okay. All right. If nobody has any other questions, I guess, David, you're such a good teacher that here for me. If you're such a good teacher, nobody has any questions. I want to thank all the members of the Hauser families who has joined us this evening in the corner of my screen. And I want to thank David again for being one of the wonderful gems of our community and for really helping to bring us all together and for studying with us. This is great. There's always that small light at the end of this challenging time, is that we're hoping this brings us all together. We've been spending a lot of time with each other online, and everyone, again, is welcome to continue to join us. A reminder that Thursday night we have, and I'm going to butcher this again. So, Jordan, tell me, what's the name of your program?
It's sangria making.
Sangria making. And it's an alcoholic beverage, Jordan?
That's correct. I hope so.
So there's no non-alcoholic beverages. Here, this week, everybody can drink heavily. So please do. And I hope to see everybody on Thursday afternoon for my class and Thursday night on the same channel, Thursday night with Jordan, and wish everybody a great night. This is my new sign-off. Stay safe and stay sane. And
Yashakar to David and to Rabbi, to all of you.
Thank you. Thank you, Hausers of Florida. Be well, everyone. Have a good night.
Thank you. Good night.
Good night.